Okay, so we're going to do two examples here for the ellipse. So I call this two ellipse examples, and you should be taking notes on your own for your own record. So I'm going to show you how to do these examples right here. So first, we're going to write the standard form of an ellipse with the vertices at -5, 1, and 1, 1, and a focus at -3, 1. Okay, I would highly suggest that you start by graphing this out. So if we think about this, the vertices are -5, 1, and 1, 1. So that's mostly quadrant number 2. So let's see here, -5, 1. So 1, 2, 3, 4, 5, 1. So this is one vertex. And the other vertex is at 1, 1. So here's the other vertex over here. So if this is my vertices are left and right, I know that this is going to be a left-right ellipse. So therefore, my center is not at 0, 0. So I'm going to have something like this: x minus h quantity squared over a squared. Because it's an ellipse, I'm going to use the plus sign. Y minus k squared over b squared equals 1. So this is what I start with. You can find that on the the ellipse cheat sheet. Sorry, not the hyperbole, the ellipse. Okay, so here's my vertices. All right. I also know that a focus is at -3, 1. So I'll change colors here, and I'll put my focus at -3, 1. So -1, -2, -3, 1. So here is a focus. So that means that the other focus has to be 2 units away as well. So here's my other focus. So it has to be 2 units away from my vertex on the other side. So therefore, my center of my ellipse has to be right here. Remember, the center has to be exactly in between the two vertices. So I'm going to go ahead and zoom in on this so we can see it a little bit better. All right. If this is one vertex over here to the right, and this is a vertex over here to the left, then I know that my center has to be between it. And so it must be the case that my major axis is right there. That's my major axis. So, okay, so if my center is at the point -2, 1, then I can now enter my equation here. I'm going to have x plus 2 quantity squared over a squared plus y, let's see here, minus 1 quantity squared over b squared has to be a value of 1 because my center is located at the point -2, 1. So that's my h and that is my k. So -2, 1. Okay, so far so good. So now remember that a is the distance from the center to a vertex. So a in this case is a distance of 1, 2, 3 units. So I can keep building this my equation up to find what it's going to be. So now I have this: x plus 2 squared over a squared is now going to be 9, plus y minus 1 squared over b squared has to be 1. So far so good. So the thing that I need now is b squared. So I'll put this back to normal view so we can all see. Okay, right there. So the thing that I want now is to figure out what b squared is. So I know the relationship between a, b, and c for the ellipse looks like this: c squared is equal to a squared minus b squared. Well, remember, the distance from the center to the focus is a distance of c. So in this case, that's a distance of 1. So 1 squared equals a squared, which is 9, minus b squared. So 1 equals 9 minus b squared. So coming up over here, so we can move over a little bit. Let's see here. So let's see here. If I had -8, would be -b squared. So b squared have to be +8. So b would have to be the square root of 8 plus or minus. So that would be the square root of 4 times the square root of 2. So b would have to be 2 rad 2. I don't really necessarily need to know that because all I need is the b squared, but if I was going to graph it, I want to know where 2 rad 2 is. But all we had to do was write the standard equation, so our answer would be something like this: x plus 2 squared over a squared, which was 9, plus the quantity y minus 1 squared over b squared, which is 8 in this case, is equal to 1, and that is the standard equation for this ellipse given vertices at -5, 1, and 1, 1, and a focus at -3, 1. Okay, let's do this one then. Write the standard form for the ellipse with vertices at 9, 9, and 9, negative 5, and a focus at 9, 6. So again, I would suggest that you start graphing these things so you can get an idea of what it looks like. Okay, so let's see here, 9, 9. So I'm going to draw this out like this, and then 9, negative 5. So hopefully this will work for me here. So, okay, 9, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So one of my vertices is here. That's one of the vertices. The other vertex is at 9, negative 5. So what's here? 1, 2, 3, 4, 5. All the way down here. That's the other vertex. So this vertex is located at 9, 9. This vertex is located at 9, negative 5. Okay. So I have a vertical major axis here, and my center is has to be halfway between them. Okay, so where does the center have to be? Let's see here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 units. Okay. So if I go 7 units down, 1, 2, 3, 4, 5, 6, 7. Okay. So this point right here must be my center. And that center is located at the point 9, up 2. All right, great. So that's my H and that is my K. So because I know that this is an up-down ellipse, it's going to look something like this. Y minus K squared over A squared plus X minus H squared over B squared has to be a value of 1. I know where my center is. My center is at 9, 2. So I'm going to have this. I'm going to have Y minus 2 squared over A squared plus X minus 9 squared over B squared has to be equal to 1. Okay, so far so good. I do know A, because A is the distance from the center to a vertex. In that case, if I count, I get 1, 2, 3, 4, 5, 6, 7 units. So if A is 7 units, that means A squared has to be 49, so I know some more information now. I have Y minus 2 squared over 49 plus X minus 9 quantity squared over B squared has to equal 1. Okay, so again, I'm in this situation where I need to figure out what B squared is. And I know the relationship between A, B, and C for an ellipse is this. I know that C squared is equal to A squared minus B squared, because it's an ellipse, the same thing like it was over here, right? C squared equals A squared minus B squared. Okay, so C is the distance from the center to the focus. So one of the focal points is at 9, 6. So if I go over 9, 1, 2, 3, 4, 5, 6. So here's the point, 9, 6, all right? And the distance from the center to a focal point is the distance of C units. That's 1, 2, 3, 4. So that must be 4 units. Okay, good. Good to know. So now here we go. So that means 4 squared is equal to A squared, which is 49, minus B squared. So I get 16 is equal to 49 minus B squared. So that means I'm going to have negative 33 equals negative B squared. So B squared must be 33. Okay, that's all the information that I need to write my final answer, which would be this. Y minus 2 squared over 49 plus X minus 9 squared over B squared, which is 33, is now equal to 1. And that is the standard form of the ellipse with a vertex at 9, 9 and 9, 5 and a focus at 9, 6. So the key is being able to make the drawing, ladies and gentlemen. Making the drawing, picking the right equation, and then using everything you know to come up with the value for B squared, A squared, and C squared. Okay, I hope that helps.